Question 1. Why do specialized 3-quadrant or snubberless triacs deliberately disable triggering in Quadrant 4? By modifying the internal gate geometry to eliminate the highly insensitive Quadrant 4, 3-quadrant triacs achieve exceptional resistance to false retriggering. Question 2. What is the name of the monolithic solid-state device that integrates a DIAC and a TRIAC together in a single package? A quadrac is a specialized power semiconductor containing a built-in series DIAC internally connected to the TRIAC gate, minimizing external component counts. Question 3. Which triggering quadrant in a standard TRIAC is universally characterized as having the highest gate sensitivity? Quadrant 1, where main terminal 2 is positive and the gate is pulsed positive with respect to terminal 1, is the most electrically sensitive region. Question 4. What happens to a triac's required gate trigger current when operating in extremely cold temperatures? As operating temperatures drop, internal silicon carrier gains fall, requiring a larger gate current pulse to successfully force the device to turn on. Question 5. What term describes the transient voltage rate of rise that a TRIAC can withstand without conducting when it is already in the off state? Static dV/dt defines the maximum rate of anode voltage rise the triac can block while resting in its non-conducting, off state without falsely triggering. Question 6. What is the primary physical component used to control AC loads inside an AC solid-state relay? AC solid-state relays use high-power triacs or inverse parallel SCR pairs to execute silent, high-speed, wear-free switching of mains electricity. Question 7. What physical parameter is used instead of static thermal resistance to calculate junction temperature rises during brief high-current surges? For short overload currents, static thermal resistance is inaccurate. Engineers use transient thermal impedance to track immediate heat absorption over time. Question 8. What critical gate parameter must be strictly limited to prevent localized hotspot destruction during the initial trigger pulse? Peak gate power dissipation, or PGM, must be limited to prevent a concentrated current pulse from burning out the delicate gate contact structure. Question 9. Why are snubberless or 3-quadrant triacs highly advantageous in modern high-temperature industrial environments? Because they are highly resistant to commutating dV/dt failures, snubberless triacs can operate at elevated junction temperatures without needing snubbers. Question 10. What advanced AC switch integrates a monolithic gate clamping structure to protect itself from overvoltage transients without external MOVs? An ACS device includes a monolithic protective structure that clamps dangerous overvoltage spikes, safely dissipating the energy without external varistors.